remember the last time you got a flu shot? The nurse ran an alcohol swab over your arm to disinfect the area. Did you know that the alcohol in the swab is a monohydric alcohol? In the previous session, we have discussed that a monohydric alcohol is an organic compound with one alcohol functional group. Let us now take a closer look at some of the different properties of alcohol, starting with acidity. Alcohols as well as phenols are acidic in nature. In fact, alcohols and phenols are Bronsted acids, that is, they can donate a proton to a stronger base. This reaction involves the cleavage of OH bond. On the base of this, alcohols and phenols react with active metals such as sodium, potassium and aluminium to yield corresponding alkoxides, phenoxides and hydrogen. In addition to this, phenols react with aqueous sodium hydroxide to form sodium phenoxides. If you see the structures of alcohol, here the electron releasing group, that is the alkyl group, increases electron density on oxygen, tending to decrease the polarity of OH bond. This decreases the acid strength. For this reason, the acid strength of alcohols decrease in the given order. However, alcohol is a weaker acid than water because water is a better proton donor than alcohol. Also, in the given reaction, we note that an alkoxide ion is a better proton acceptor than hydroxide ion, which suggests that alkoxides are stronger bases. Thus, alcohols also act as Bronsted bases due to the presence of unshared electron pairs on oxygen, which makes them proton acceptors. If you see the structure of phenol, the hydroxyl group in phenol is directly attached to the sp2 hybridized carbon of benzene ring, which acts as an electron withdrawing group. Due to this, the charge distribution in phenol molecule, as depicted in its resonance structures, causes the oxygen of OH group to be positive. The reactions of phenol with metals and sodium hydroxide indicate its acidic nature. Do you know the compound in which hydroxyl group attached to an aromatic ring is more acidic than the one in which hydroxyl group is attached to an alkyl group? Let us understand the reason behind it. The ionization of an alcohol and a phenol takes place as given here, and due to the higher electronegativity of sp2 hybridized carbon of phenol to which OH is attached, electron density decreases on oxygen. This increases the polarity of OH bond and results in an increase in ionization of phenols than that of alcohols. Here, in alkoxide ion, the negative charge is localized on oxygen, while phenoxide ion, the charge is delocalized. The delocalization of negative charge makes phenoxide ion more stable. In substituted phenols, the presence of electron withdrawing groups such as nitro group enhances the acidic strength of phenol. It is due to the effective delocalization of negative charge in phenoxide ion. On the other hand, electron releasing groups such as alkyl groups in general do not favor the formation of phenoxide ion, resulting in decrease in acid strength. Here, greater the pKa value, weaker the acid will be. For examples, cresols are less acidic than phenol. From this data, it is also clear that phenol is million times more acidic than ethanol. Alcohols and phenols also undergo esterification with carboxylic acids, acid chlorides and acid anhydrides. The reaction with acid chloride is carried out in the presence of a base so as to neutralize hydrochloric acid, which is formed during the reaction. It shifts the equilibrium to the right hand side. Alcohol also undergoes acetylation, whereas an acetyl group is introduced in alcohols or phenols. For example, acetylation of salicylic acid produces aspirin. Now, can you arrange the given compounds in an increasing order of their acidic strength? Well, try to figure out. Now, let us summarize what we have learned.
Manorama Horizon. Learning made simple.